Yes, is this the right page? Am I on the wrong page? 225, thank you. Yes. Okay. So here, the red graph is our original graph. The blue graph is our image graph. And they said that there has been a whole bunch of combinations. So if we think about how would we solve this, if we think about if we had an equation, we would have started with, and you don't have to write this down, we would have started with a point on our original graph. Then we would have done one thing to find a point, and then one thing to find another point. That's what we've been doing. And first, we always did our stretches, compressions, and reflections, and then we did our translations. This is important for understanding this because as far as what I'll get you to write down, what are our steps going to be in this question? And we started the steps already in the previous section. In 3.3, we had a similar question that just had horizontal and vertical stretches happening. So the steps are, well, if we would do our stretches first, the first thing we have to find out is how has this graph been stretched or reflected. So step one, I'll use black. Step one is we have to find our stretches / compressions. After finding our stretches and compressions, we are going to graph with the stretch or compression. So we're going to look at what does that graph look like if we stretch it or compress it. And then step 3, we are going to find the translations. And once we've found our translations, we are going to be able to write the equation. Okay. So those are the steps that we're going to look at. In order to find the stretch and compression, here I'm just going to everybody got these written down? No, not yet? I'll wait for you. So the idea of these steps are based on when we did our work with our points, we always did our stretches and compressions first. Then we did our translations afterwards. So if we're working with two graphs, we have to figure out what we had to do first was our stretch, and then we're going to have to figure out how it's been translated. Everybody got those steps written down now? Okay, I'm just going to make them a little small for a second. Hopefully you can still read them. So how do we figure out our stretch and compressions? Yeah.
On one of the graphs and then compare it to another point on the same graph.
Yep. So we're talking about our vertical distance first. And we're going to look at our original graph, which is our red one. And we can look at point A to B. And then we would have to look on our blue graph, the corresponding vertical distance from A prime to B prime. What is the distance from A to B? I'm going to be really fussy here. Vertical distance. Okay, 16 is close. I said I was going to be really fussy. -16. because you're going from A, which is up at the top, down to B, so you're going down 16. And it's important to write negative 16 because in your homework questions, sometimes A to B will be negative in one and A prime to B prime will be positive. So there's been a vertical reflection then. So if you're careful and fussy in this, you'll be able to tell if there is a vertical reflection or not. In our example, when we're also fussy from A prime to B prime, it's gone down negative 8. So had you not been fussy, you would still get the right answer for this one. But you might, when you get to your homework examples where one of them is going up and one of them is going down, you would miss that vertical reflection. So what's happened to the y values? They've been multiplied by a half. And again, we're always, when we're figuring out, we're going from our original to our image graph to figure that out. So if the A prime to B prime was the 16 and the A to B was the 8, then it would be by 2. We still need to find our horizontal distance as well. And again, we look horizontally from A to B and horizontally from A prime to B prime. We're fussy again. From A to B is positive 2. From A prime to B prime is also positive 2. We can write x by 1. But nothing's happened, right? There's going to be no horizontal stretch or compression in this one. So, now when we go back to our steps up here, we've done step 1, as you can read. Step 2 was, we now graph that, here. Step 2, graph with the stretch. So, we need to multiply our y values by a half. We need to not do anything to our x values. I'm going to show what happens to point A and what happens to point B with just that. So the only thing that's going to affect it is our y values. When I multiply by half, do you see that this A would go to 4 and B would go to negative 4? By drawing those 2 points, it's going to be easy to count the translation now. Because that would have been our first step, the stretch. And those would be the 2 points that we would get as our first coordinates as we went from left to right in our points. Now, can you see how you could move these 2 points? Here, I'll group them together. Whoa, that didn't work. Can you see how we're going to have to move these points? We're going to have to move them how much to the left? 2 to the left. And how many down? 4 down. Remember, this is going by 2's. So we can now, by just graphing, by doing step 2 and graphing those points, we can now see that you need to move 2 to the left and down 4. That was step 3, and finally now we can write our equation of our blue graph. Y equals, what was the function in terms of f? Okay. We have y by a half. That will be outside our function. Inside our function, there is no horizontal stretch or compression, but we do move 2 to the left, so that would show up as x plus 2, and then after we move down 4. So to recap, we did those 4 steps. We found out our vertical and horizontal stretches and compressions first. Then we graphed what would happen to our points A and B after that. That helped us find where A prime and B prime would be. And then we could write our equation. All right, let's try question number 9.